Hey everybody, it is me, Steve, and today is going to be kind of like an extension of my last Ice Age video, which was called the Wisconsin episode in the Midwest. This is going to focus more on Illinois and Indiana. As a matter of fact, it's called Illinois and Indiana Landscape. But here I'm going to get into a little more details. The last video I made that I just mentioned, that was a zoomed out view, and I did make a couple of errors, and I apologize for that. But I'm going to leave the video up because it's still useful. If you look at this here, you'll see I put the timing, and as you'll see later, I put the timing of Lake Chicago in the wrong place. I put it behind, I think, a couple thousand years. But this video will correct that. This video is a lot more accurate. I used the end moraines from Illinois, Indiana, and Ohio in order to generate this. Now, all right, it's going to be similar to the last one. When I'm done ranting here, I'm just going to shut up and let you watch the Ice Age from the Wisconsin episode just advance and retreat, and with big lakes, with large lakes that formed. Slackwater lakes are not included. All right, but if you look at this here, what you see is on the bottom is the age in years before present. And I decided to do this actually in radiocarbon years. So 1950s considered present. All right, but much hasn't changed since then. If you look here, what you see is you see a bunch of different names, not like Wisconsin Holocene, but you see age and episode and stage and substage. Well, what is the difference with all these units? Well, they're different chronostratigraphic units is what they are. And I'll get into this. I'll do a detailed thing about this later for a different time because it's really in depth. But here, as you can see, this is just from the North American Stratigraphic Code, the most recent edition's 2005, and it defines these things. But you got to remember, episodes and phases are a little different. They are time transgressive units. In other words, a phase may begin in one area earlier than it does in another area and may end in one area earlier than it does in another area because it's based. We usually use it just for glacial purposes. We don't usually use it for marine for marine transgressions and regressions. It's mostly used for this type of thing. But that's just what I'm going to say about it for right now. And just so you know, down here, the phases, well, it's time transgressive, but I picked actual dates. What I did was I used Illinois as my base, and the oldest, the very first appearance of that phase till its disappearance is what that time frame is. All right. I had to pick it just for consistency purposes and to show you what's going on. But like I said, these are transgressive units, and you can actually have multiple phases happening simultaneously, which we do have in the Wisconsin. But I'm only addressing the diamicton or till units in this video, and you'll see and as you can see here, the Holocene age is different than the Holocene epoch because they're two different. They're two different chronostratigraphic units. The Holocene age begins later than it does on the global scale. The Holocene epoch, the yellow part's the global scale, and actually the International Stratigraphic Code puts it at 11,700 years before present. And the GSA one puts it at 10,000 years, so I've picked 11,000 as a compromise. But so we still can use the same word for different things. That's kind of there's been a move away from that because they have something called the Holocene epoch and also the Holocene age and stage. It's a bit redundant and kind of confusing. But like I said, there's been a move in the past 20 years to give things different names so we don't reuse them. Even though in chronostratigraphy there's nothing that says you can't do that. On lithostratigraphy there is. But these time units are solely time-based. They're not based on actual rock units. Stages and sub-stages kind of are. But stages, sub-stages, they are... they have definite beginnings and ends, all right? As where episodes and phases do not over a larger area. And episodes and phases tend to be more local, as where ages and sub-ages and series, which aren't on here, tend to be more global in scale. These tend to be more localized. So that's just a quick, not so quick explanation of that. But if you see here in this slide, these are the cities for reference. My base maps were the county outlines of Illinois and Indiana, and then I just used the neighboring state borders for the rest. I did not put the county names on there because I'm not going to sit there and put over 200 county names on here. You wouldn't be able to read it. But I put the major or larger cities on here just so you could have a good reference point. And you'll see, like at the top, you'll see Woodfordian sub-age, because during the Wisconsin episode at the beginning of it, the ice didn't reach this far south. All right, it wasn't until the Woodfordian sub-age that it did. And that's about 28,000 to 11,000 years ago, which, the beginning of the Holocene is the end of it. So that's where I'm going to start this slideshow. And if you look back at I hate to jump through like this, but on this last slide here with the timeline, with the time scale, you see these red circles with an X in them. Those are where the slides are. The slides appear that I'm going to show you. And the slides are not in even increments like my last video, which was every 1,000 years. This is just to show you major changes in ice advance. So some will be clustered, some will be spread out. And so that's just remember that as you watch this. But anyway, I am going to shut up and show these slides to you, and I hope that you learn something.